We're going to use the definition of the derivative to differentiate f of x equal to cosine of square root of x. To do it, we'll require two results. The first result is the trig identity cosine of alpha minus cosine of beta equals to minus 2 times sine of alpha plus beta over 2 times sine of alpha minus beta over 2. And the second result we're going to need is the limit as y approaches 0 sine y over y equals 1. So we're going to need these two results. Recall the definition of the derivative. F prime of x is defined as the limit as h approaches 0, f of x plus h minus f of x divided by h. And let's apply this result. Let's apply this definition to our function cosine of square root of x. So the derivative of cosine of square root of x is equal to the limit as h approaches 0 cosine of square root of x plus h minus cosine of the square root of x divided by h. We are going to treat this square root of x plus h as alpha and square root of x is beta. So using result number 1, we can rewrite this limit as the limit as h approaches 0 minus 2 times sine of square root of x plus h, that's alpha, plus square root of x, that's beta, divided by 2 times sine of square root of x plus h minus square root of x divided by 2 all over h. Now the next step, if we try to plug in 0 for h now, we'll get an indeterminate form 0 over 0. The next step is to modify the denominator. Not change it, just modify it. And the way we'll do it, we'll take x plus h minus x. Didn't change anything because x minus x is 0. That still leaves an h. Now I'm going to put parentheses around x plus h. Now the reason we're doing this is because now we can factor the denominator. The limit becomes a limit h approaches 0 minus 2 times sine of square root of x plus h plus square root of x divided by 2 times the sine of square root of x plus h minus the square root of x divided by 2, and the denominator x plus h minus x factors into square root of x plus h minus the square root of x times the square root of x plus h plus the square root of x. Now we're going to take this limit and break it up into two limits. The first one is going to be limit as h approaches 0 minus 2 sine of square root of x plus h plus square root of x divided by 2 divided by the square root of x plus h plus square root of x. The reason we break it up into this limit is this one is easy to evaluate, but just plugging in 0 for h times limit as h approaches 0 of the rest, which is sine of square root of x plus h minus square root of x divided by 2 divided by square root of x plus h minus the square root of x. Now let's look at the first limit. The first limit, plug in 0 for h. As h approaches 0, we get minus 2 times the sine of, we get square root of x plus square root of x, that's 2 square root of x divided by 2. And in the denominator we have square root of x plus square root of x, that's 2 square root of x. So these two cancel and we have minus 1 left in the numerator. These two also cancel. For the second limit, first we're going to do the following. We'll multiply this by 2 over 2 and we'll take the 2 in the numerator and filter it out. Since it's in the numerator, it becomes 1/2 times the limit as h approaches 0 sine square root of x plus h minus square root of x over 2, and this is divided by square root of x plus h minus square root of x, also divided by 2. Now let's rewrite everything. We have minus sine of square root of x divided by square root of x times 1/2. And now for the second limit, let's do the following substitution. Let y equal to, so I'll do that over here, let y equal to square root of x plus h minus square root of x divided by 2. Notice that as h approaches 0, y will also go to 0 because the numerator will be square root of x minus square root of x. So the second limit can be rewritten as the limit as y goes to 0 sine of y divided by y, and that's our second result. This limit is 1, and that gives us the final answer, which is minus sine of square root of x, and then the 1/2 times square root of x in the denominator gives us 2 square root of x in the denominator. So let's summarize what we did. We started out with the function f of x equal to cosine of square root of x. Using the definition of the derivative, we found that the derivative of this function is equal to minus sine of square root of x divided by 2 square root of x.